welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're gonna be talking about core channel with an active and hot standby link over Q&Q tunneling. Let's get inside the details on both technologies and the advantages that it provides on your network. Let's start with Q&Q. And Q&Q, also known as VLAN tagging or double VLAN, is standardized by IEEE 802.1AD. It encapsulated the VLAN tag with two layers, double tagging, an inner tag of a private network and an outer tag of the public network. I'll be providing more details about the C tag and the S tag later on. Let's get inside the details on port channel. Port channels aggregate multiple physical interfaces into one logical interface to provide higher bandwidth, low balancing, and link redundancy. A port channel performs the following functions: increase the aggregate bandwidth on a link by distributing traffic among all functional links in the channel, load balances across multiple links, and maintains optimum bandwidth usage, provides high availability. If one link fails, traffic previously carried on this link is switched to the remaining links. If a link goes down in a port channel, the upper protocol is not aware of it. To the upper protocol, the link is still there, although the bandwidth is diminished. The MAC address table are not affected by link failure. With that said, we're going to be using LACP as the Ether channel protocol. And in order to create an Ether channel, you need to make sure that all interfaces have the same configuration. And that applies to duplex, speed, native and allow VLANs, switch port mode, if it's access or trunk. Now that we have explained a little bit about both protocols, let's dive into the lab details. All right, so for the lab scope, the first thing we're going to do is configure ISP switches with .1Q tunneling to pass VLAN 20, which is the C tag, the customer tag, using S tag 123 and 124, which are pointing out to Ethernet 0/0 and 0/1. Also configure the L2 protocol tunnel, point-to-point LLCP. This is going to help us to pass LACP messages using the Q&Q configuration. Configure ISP switches port Ethernet 0/2 to pass S-tag 123 and Ethernet 0/3 to pass S-tag 124. Configure LACP system priority to 100 only on the HQ switch. Configure interface port channel 1 on both HQ and branch switches and will configure trunk on their PO1. Configure LACP fast switchover on PO1 interface and also LACP max bundle of 1. The explanation on the fast switchover is then when an active port in an Ether channel fails without LACP fast switchover, the entire PO can momentarily go down because LACP must renegotiate the channel with the remaining links. This is when fast switchover command comes into play to maintain PO active. Configure LACP port priority 100 on interface gig 1. Gig 2 will be designated as hot standby. Bind interface gig 1 and gig 2 to the port channel group 1. Remember, the port configuration needs to be configured exactly as the PO interface. Configure LACP rate fast on primary interface gig 1 on both HQ and branch switches. Configure VLAN 20 on both HQ and branch switches for management purposes. So let me break it down to you. We're going to have a VLAN 20, which is going to be the C tag running on HQ. Both ISP switches are going to be running S tag 123 and 124, which is going to transport LACPs and VLAN 20 all the way to the branch, which also has C tag of 20, which is VLAN 20, and is also going to receive LACPs. So the branch and the HQ will be able to form the Ether channel and also receive traffic from VLAN 20. So now that I have explained a little bit about both protocols, let's get into the CML and let's get started with the configuration. Okay, so we're inside the CML. I wanted to state before we start that I'm going to be using CSRs 1000B as switches because it has all the port channel configurations that we need. So everything else is pretty much the same. We're going to be using two switches for the ISPs. Let's get started. All right, so first up, we're going to be configure ISP switch number one with VLANs 123 and 124, which are the S tags that we provided on the lab. And first, we're going to configure Ethernet 0/0 with VLAN 123 and 0/1 with VLAN 124. And we're going to provide the Q and Q configuration there and also provide another configuration to be able to pass LACPs using that .1Q tunnel. And we're also going to be configure Ethernet 0/2 to pass VLAN 123 between the ISP switch number one and ISP switch number two. And we're going to use Ethernet 0/3 to transport VLAN 124 from ISP switch number one to ISP switch number two. So as you can see, I typed L2 protocol dash tunnel space point dash two dash point space LACP. That's the command that we need to pass LACPs using that .1Q tunnel. So we're gonna do it now a show run just to verify the configuration and all the ports as they need it to be, and also just verify the VLAN database and just make sure those VLANs are there as well. Alright, so ISP switch number one is already configured. So let's jump into ISP switch number two and let's get started with the configuration as well. And so ISP switch number two is going to be configured with VLAN 123 and 124 as the first task. The second task is going to be to configure Ethernet 0/0 with the .1Q tunneling and the L2 protocol to be able to pass LACPs. And Ethernet 01 is going to be configured with VLAN 124 with the same tunnel and L2 protocol that we configured first on Ethernet 0/0. And we're also going to configure the trunk ports, which are going to be Ethernet 0/2 to carry VLAN 123 and Ethernet 0/3 to carry VLAN 124. Alright, so we're inside the HQ switch now. We're gonna start configuring the LACP system priority to and set it up to 100. And then we're gonna go ahead and configure the interface PO1, which is gonna be the Ether channel interface. And we're gonna configure all the LACP max bundle and fast switchover. Alright, so let me explain to you the LACP max bundle. I set it up into one because I just want one interface inside the bundle to be able to forward traffic, and that forces the secondary link to be in hot standby. And then the LACP fast switchover, what it does is maintain the interface PO1 active instead of going down and having again to renegotiate the channel with the remaining links. What we're gonna do now is we're gonna configure G1 with the LACP port priority of 100, and then we're gonna go ahead and do a range of interfaces to configure the channel group both at the same time. As you can see, I put the LACP port priority to 100. This works exactly like the bridge ID on spanning tree. So this port is going to be elected as the primary because of the port priority 100 configured on it. And the other one is going to be in hot standby because it has the priority of 32,768. So we're going to go ahead and configure PO1.20, which is going to simulate VLAN 20 since we're using CSR 1000V as a switch to simulate VLAN. And we're going to test layer 3 connectivity once the branch switch has been completely configured. My apologies, I had to go back to HQ. I forgot to put a command on G1. Alright, so let me explain about the LACP rate fast. The LACP rate fast feature is used to set the rate once every second at which the LACP control packets are sent to an LACP supported interface. The normal rate at which LACP packets are sent is 30 seconds. Okay, so we're gonna finish up configuring the branch switch with all the configurations that we actually did on HQ. It's gonna be the same. Gig 1 is gonna be the primary interface for the LACP, and all the configurations regarding LACP are gonna be configured on this side as well. And also we're gonna be configuring the interface PO1.20, which is gonna simulate the VLAN 20. As you can see, port channel came up, and Gig 1 was actually added as a member of the port channel. Now that we finished configuring the branch device. Let's verify layer 3 connectivity using VLAN 20. As you can see, we got a response from the other side. Let's do a show LACP internal. And as you can see, G1 is the one that is preferred and is the one who's actually participating on the bundle. And G2 is actually in hot standby. Let's go inside HQ switch now and let's do a show LACP internal. And as you can see, Gig 1 has been selected for the bundle and G2 is in hot standby as well. So I'm just gonna do now an extended ping to 192.168.1.2, which is running on VLAN 20 on the branch switch. And I'm gonna disconnect G1 from HQ side, and you're gonna see when it goes off the bundle and when G2 gets promoted to run on the bundle. And as you can see on the log, Gig 1 was taken off from the port channel and Gig 2 was added as a member of the port channel. If I do a show LACP internal, you're gonna see Gig 2 on the bundle and Gig 1 is being suspended because he lost connectivity. Now what we're gonna do now is we're gonna enable again G1 on CML, and you're gonna see Gig 2 leaving the bundle and Gig 1 being added at the bundle again. We're gonna do a show LACP internal on both ends, and you're gonna see that G1 is already in the bundle and G2 went to hot standby again. If you like the content, please give it a like. And as always, this is Julio. I'll see you in the next video. Peace out.